Stress Engineers Log, Stardate 2011-06-20. Bad news, everyone! I didn't learn anything particularly interesting today, which means I'm going to live up to all my dangerous promises and teach you a little bit about statistics. So yes, statistics. I don't like them very much, so hopefully I'll be able to tell you what they mean and get it across. First thing you need to know about are distribution. So what is a distribution? It's a graph. It's a graph of the probability, P, that something's going to happen, usually from 0 to 1, 0 being it'll never happen, and 1 being it's certain to happen, versus whatever observations you're making. So you're taking your observations and seeing what their likelihood is. This is pretty well illustrated by using your basic die. You have 6 possibilities, 1 through 6, and you have a 1/6 chance of getting either one of those. So the area underneath that straight line there is your probability space. That is your distribution. As you can tell, it's a flat line because you have an equal probability of getting any particular result. What you oftentimes see is the normal distribution, which maxes out at about 40% and is that familiar bell curve shape. I'm not going to show you the math because it's a nasty looking equation, but it gets used very often because it's a surprisingly good model for chemical reactions, grades, and target shooting. So, where do we go from here? It's centered around a particular value called mu, which is the average of your observations. Sometimes it's not actually the average of your observations, but what you think the average is. And in that case, you'll have boundaries on either side of it defining, well, if my observations fall within these two lines, then yeah, I'm probably right. The distance usually between those two lines is about 95%. So for a normal distribution, that says that 95% of the time, if that's an accurate distribution, the values will fall within that area. Now, the actual definition is more along the lines of if you have a normal distribution and you're modeling it with a normal distribution and you're actually correct, then the test will actually correctly detect that it's a normal distribution centered around that mu 95% of the time. But that's kind of tricky, so we'll just go with the simpler, you have a 95% chance of being right. So if your average, your observed average, lies between the two lines that are acting as limits, as shown as the red line here, then yes, your distribution is accurate. You can consider it to be close enough to mu that your assumed mu is accurate. On the other hand, if it is outside of that range, then it probably falls outside that distribution. This is where you get ideas like outliers and whatnot. Now note, your actual mu could be what you think it is. It's just that your data says it's not. It's still possible, it's just very unlikely. So what does this all mean if we look at our scientist person here? Well, if a scientist is saying that they have a 95% confidence of something, they're saying that whatever they're observing falls within that area between the 95% lines on this little graph here. Now, it's possible that they're wrong. There is a 5% chance that their observation is actually part of some other distribution, but that is just simply accepted. 95% is kind of the standard thing. Well, that's actually come into play in recent news having to do with climate change. Considering that 95% is your standard significance, that's what statisticians call it. If it's not within that range, it's considered significant because then you can reject it. We're going to have this green line here represent no climate change, and we're going to have this red line here represent climate change. These are the predicted mu's, let's say, the predicted averages of the two theories. And the center line is just going to be what's actually going on and what's being observed. As you can see, both of your hypotheses, both of your predictions are within that 95% confidence range. So you can't say with 95% confidence that there's a difference between the two. They're both equally likely, more or less, to be in the same distribution. Now, what happens is as you get data, as you acquire data points, you collapse the curve. You start making it thinner and taller as you start narrowing down just how broad it can be. So you can then make comparisons. And what they said recently is that your 95% confidence level now accepts the global warming theory, but does not accept the no global warming theory. So that's what they mean that it's significant now, but it hasn't been for quite some time. Well, I hope that was fun and educational. I know it has been for me. Hooray! Log ends.
12:45. Restate my assumptions.